embarrassing.
Alright, so we've got the homework here, mole ratios. We're reviewing. It is question number 1, is the bell work? So can anybody come up here and do this for 5 points? Alright, so the second one, this is your mole ratio. Mole ratio, this equals 1. Can anybody come up here and do the last one? So Adam wrote this last one up here. Good job, Adam. We have 6 different mole ratios.
Silica and 6 of water. The coefficients balance the equation, and numbers of each kind of atom appears on both sides. How do we find these coefficients? Bigger than A of U, that is 1 gram equals 6.022 times 10 to the 23rd AU. This is the number of particles in a mole. A mole of anything has this.
This is correct. He did the first one. You can see that this would be your true ratio. It's a true ratio. This one's going to cross out, true ratio. And then obviously you got this one crosses out. So how many true ratios do you have here? Right, so we've identified 6 mole ratios from this balanced equation. Anybody want to do the next one? Yeah, there's 3 of them on the homework. We're going to do all 3 because we got the ACT going on today. Because the ACT is happening, we're just kind of reviewing a little bit. Anybody want to do the next? Oh, no, I'm not going to do that.
Do I get the word points first?
Yes.
Can I do the last one?
Yes, you may. I like how you went high because it's easier to write up than it is down. It's hard to write like straight across. Students can also see it when it's higher.
Okay, I'm just gonna do this.
Okay, you're doing a little bit of improvising.
Yep.
That's good. So the first one
over again.
crosses out.
Huh?
This one will cross out. It's the same thing.
Then I'll start with this one. No, this one, right?
Mm-hmm. It's got like a mathematical code going on there.
Coefficients in front of them. The equation means 3 molecules of kaolin clay field, 1 molecule of bullet, 4 of silica, and 6 of water. The coefficients balance the equation. The same number of each kind of atoms appear on both sides. 6 Al, 6 Si, 27 O, and 12 H. Do we find these coefficients? Start with an unbalanced equation. Write down the number of atoms on each side. Balance one element. We start with Al. Multiply by 3 on each. On the left by, I can't read that. It's not even marked up. Alright. Again, count atoms on each side. Balance another element. We can balance Si by putting a 4 in front of SiO2. Again, count atoms on each side. Finally, a 6 in front of the H2O balances the H and the O.
Alright, so you can see this is a different method or a new method to balance equations where they've set up a data table where they have the element like Al, then they have the left and the right. So on the left of the equation it would be the reactants. You have 2 aluminums, and on the right would be the products. You have 6 aluminums. And they do this for all of the elements there, silicon, oxygen, hydrogen. And the goal is to get both sides equal. right? So you can see at the beginning they have 2 and 6, and the second data table there they have 6 and 6, but the silicon has 6 and 3, so it's not balanced. Third table you have aluminum with 6 and 6, silicon 6 and 6, oxygen has 27, and that would be 27 in the reactants, 22 in the products, still not balanced. And then the last one, you can see that they all have the same number in the reactants and the products. Oxygen 27, 27, hydrogen 12 and 12. So they've created 4 data tables for this one balanced equation. I would recommend doing it this way if you're not getting the boxed in method that we showed you about a week ago.
Alright, this is my question. So, if I go to the Capitol, right, I got a baseball game that day. Am I allowed to play in that game, even though, like...
It is an excuse. It's basically a school recognized
So, like, I'm
field
practically
trip.
there,
Oh,
but...
you are there. That's
Okay.
why you have the permission form right there.
Gotcha.
You're not missing school. You're actually taking advantage of a reward.
Is this for you too? Alright, I gotta get on these. Oh!
I need a restroom pass. Cameron decided to take us to his Miami game. Should have done that. I don't know why though. I'm waiting. I'm
Right, so we're trying to color this. This is kind of a review. We're going to read about it here just a second.
Am I doing this right?
Yep, it's really good.
Yield 1 molecule of blue light, 4 of silica, and 6 of water. The coefficients balance the equation. The same number of each kind of atom appears on both sides. That. How do we find these coefficients? Start with an unbalanced equation. Write down the number of atoms on each side. Balance one element with...
If you remember back a week ago, we had the block method where you would block out the substance on the equation, then you would just add to it. Now this method creates a chart. So you can see the chart here that they've created. It's a lot of work. They have 4 different charts here. Does everybody see they have 4 different charts? That's a lot to keep track of. It's a lot to do. Oftentimes, you don't have time when you're working places. Time concerns money, and money concerns, whether you want to get paid or not. So if you're wasting money, even if you're taking a test, if you don't have enough time, you just took the ACT, so many of you understand how time really plays a big role on your success.
Unit called the mole. 1 mole of substance is the amount whose mass equals the molecular or atomic weight of the substance expressed in grams. That's a kind of a mouthful for a simple idea. Let's illustrate by example. Illustration. Note, here molecular weight really means the mass of basic particle of the substance, expressed in AMU. In an ionic crystal like NaCl, we mean a basic component of the crystal. Thank you.
All right, now if you look at the table here where it says O2, you'll see molecular weight. Molecular weight is always an AMU. Raise your hand, 5 points. What's AMU?
I'm Andrew Heckle. Dismissed.
AMU?
Atomic mass unit.
Atomic mass unit, that's typically just 1 unit, right? So for O2, 1 unit of O2 would be 32 AMU. So that would be just O2. Does everybody understand? Any question on that? Just O2? Oxygen is typically diatomic. That's why you saw it 32. But 16 here represents a number. Now you have to identify that number either as AMU or grams. You have 2 possibilities. AMU or grams. Just like this is showing you on this sheet. You have to define it. It's either molecular weight or molar weight. If you're talking about molar weight, it's going to be in what? Raise your hand, 5 points. No. We said molar weight. No. It's on the paper. Grams. Thank you very much. Why is the molar weight important? Because it corresponds to a mole of things, like you see on the chart behind us.
Or has this many particles, 6.00 or 6.022 times 10 to the 23rd. It's called Avogadros number, after Amedeo Avogadro, who first suggested that equal volumes of gas have equal number of, where's it go?
Particles.
Particles.
All right, so the question is, what was used to count the moles? We got this big number. What unit did they use to count the mole? Raise your hand, 5 points. They got this big number, 602 sextillion. What did they use to count it? Did they use their eyes? No, you couldn't use your eyes. Somebody said it, raise your hand. They used the electron, remember? They had a solution of what? What element did they use to count? Use the electron. No. 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 No, we talked earlier. Francesca? No. No. Some people are born with this in their mouth. No. 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 No.
We're talking about elements.
Type of spoon.
Silver.
You have to determine the mole ratios. I think that this 2 and this 2 would be in common because they also have C's on them. Bro, what are you doing?
Now you're
only did 5 next,
Emma, you seen this? This is crime. See, that's gonna be hard. Just erase it all. Good job. All right. Flip it over to the back. All right. So you have to draw all of this up. So divide everything by the first one. So it's WO3, and then over WO3, and then this is over WO3. This is W over 3, and then that's W over 3. Not straight under it, because you're gonna have to do a lot. So it's right here. WO3.
Right a line?
Yeah. No.
You just
Actually.
a line or no line?
Right, WO3.
Okay.
Okay, and then just rewrite the whole equation.
Get that excellent instruction. Noah, you're a champion. Emma might make the first ever snow woman. She's gonna be a rebel. No more snowman.
Everything that means.
It's snow woman. This was inventory. You could convert and determine what you needed to order. Like this could be so many shirts in a box, so many pieces of bacon in a package, things like that. This is the method we talked about 2 weeks ago, where you box things in, you're trying to balance. You see you have 1 oxygen here, you have 2 there, so you add another water, now you have your 2 oxygens. When you do that, you double the hydrogens, and you draw a line, add it up. So there's more than one way of doing this. You can do like the data table here they're showing you. That's a lot of work. They have 4 data tables here, and if you want to write all 4 data tables, that's fine, but just remember time is money. And if you're slow, you're going to earn less money typically.